Another question. Choose the correct answer. Number 1. If M and N are two circles touching internally, then the distance between the centers of circles equal the difference of radii. So Mn equals 5 minus 2 equals 3. Number 2. M and N are two circles touching externally. The radii 3 and 5. Then Mn will be the sum of radii. 3 plus 5 equals 8. Number 3. M and N two circles of radii 3 and 8. And Mn equals 5. So in this case, the difference between the radii equals the distance between centers. This is the case of touching internally. M and N two circles radii 7 and 5. Mn, the distance between the centers, is 12. So 7 plus 5 equals 12. So the distance equals the sum of radii case of touching externally. Number 5. M and N two circles radii 4 and 3. Mn 9. So the distance between the centers greater than the sum of radii 9 greater than 7. Then the two circles are distant. Number 1, we want to find measure of angle BMN. But we need to connect the ray MN with the point A. Then measure of angle NAB 90 degree. To find the measure of angle BMA, we will subtract 40 plus 90 from 180 equals 50 degree. The second one, we want to find measure of angle EMN. So we need to connect the ray MN with the point A. Then measure of angle BAN equals 90 degree, tangent with radius. And since E is a midpoint, then ME perpendicular to DC, then measure of angle MEC 90 degree. To find measure of angle N, we will subtract the sum of 90 plus 70 plus 90 from 360 because the figure AMEB is quadrilateral. Sum of their measures equals 360. Then measure of angle EMA equals 110. The third one, we have three touched circles. Their radii. Circle M, its radius is 3 cm, N 2 cm, D 1 cm. Let's complete the radii length. It will be ND equals 1 plus 2 equals 3. NM 2 plus 3, 5. MD 3 plus 1, 4. So their sides equals 4, 3 and 5. These sides form right angle because 5 power 2 equals 3 power 2 plus 4 power 2. In this case, the longest side is MN, the opposite angle for it, angle D, So measure of angle MDN equals 90 degree, the inverse of Pythagoras theorem. Number 4, we want to find the length of BC. First of all, the distance between the centers M and N equals 5 cm. In the case of internal touching or touching internally, the distance between the centers equals the subtract between the radii. So, if MC is a radius equals 5 power 2 minus 3 power 2 equals 16 using the square root. So NC equals 4 centimeter. So the radius of the small circle is 4 centimeter. And the distance between the centers 5. To find the greater radius, we will add them. 5 plus 4 equals 9. 9 minus 3 equals 6. Number 5. We want to find the length of side MB. First of all, the radius of the circle N5 and M8. We can find the distance between the centers because the circles are touching externally equals the sum of radii. So Mn equals 13 centimeter. In this case, we have radius NB and tangent MB. The angle between them equals 90. Then triangle NMB is right angle triangle. To find the right side MB, we will subtract 13 power 2 minus 5 power 2 equals 144. Using the square root equals 12. The last one, we want to find BC, and the givens are the radius of the small circle 5 and the greater circle 8. To find BC, let's connect the radius NB from the point N to the radius MC to form right angle triangle. In this case, the distance between the centers of the circle, it will be 5 plus 8, 13. So NM equals 13. And from the point of connection between the radii, it will be classify the radius MC into 5 centimeter and 3 centimeter. Then to find this line, we will subtract 13 power 2 minus 3 power 2, and using the square root, it will be 4 root of 10. Now with choices question for the lesson of identifying the circle. First of all, it's possible to draw passing through a given point. We can draw an infinite number of circles passing through a given point. Number 2, the number of circles which passes through two given points is an infinite number of circles. Number 3, the number of circles passing through three non-collinear points is one circle. We can draw one circle through three non-collinear points. The figure which the circle doesn't passing through it versus is, first of all, we can draw a circle passing through the vertices of a square, rectangle and triangle, but we can't draw a circle passing through the vertices of rhombus. Number 5. The number of circles that can pass through 3 collinear points is 0. We can't draw a circle passes through 3 collinear points, so equal 0. Finally, all circles which pass through the point A and B, their centers lie on the axis of symmetry of AB.